Okay, so in this section, we're finishing off 4-5 in this video. And again, you can see that I've done some derivatives ahead of time. So looking at this function, first off, I meant to add that we are going to define this from negative 2 pi to positive 2 pi. So this is the only section of the graph that we're going to look at. X and cosine are both defined on this entire thing. So the domain is going to be negative 2 pi to 2 pi. And we can talk about those y-intercepts really easily. Again, just plugging in 0, and cosine of 0 is 1. So plugging in 0, we get 1. But the x-intercepts with this kind of function are really complicated. We don't have any algebraic ways to solve for these. This is called a transcendental function. And so the best you can really do is approximate them with a graphing calculator and using that root function. So I'm going to show you kind of how to do that real briefly. Hopefully we already know how to do this, but if I were to type in this function and I have x plus cosine x, and I were to graph this, we can see it does in fact cross the x-axis, and we can actually see the shape of the graph, so we can see where we're going to end up with this. But I would go ahead and use the calc function. So we can find a 0, and we need to choose something to the left of that value. So I'll go ahead and press enter, and then moving to the right and enter, and then let's get close. This is our guess. And press enter, and we'll say negative 0.7. We'll just round to 1 decimal place. So that would be negative 0.70 is our x-intercept. Okay, now the reason why I'm really not worried about you using a graphing calculator is because when I'm grading these problems, the graph that you come up with is the least amount of points. Showing me all of this, showing me the work for all of that is where most of your points come from. Anybody can type something into a graphing calculator and copy it, so that doesn't give you a whole lot there. Symmetry, again, plugging in negative x is not equal to this being multiplied by a negative. It's also not equal to the function itself, so there's none. And then end behavior, well, talking about end behavior when we have a defined interval here that we're looking at, we're not looking at what happens as it goes off to infinity. If I were to ask you what the end behavior is, it would really just be plugging in these values. So if we plug in negative 2 pi, well, that would be negative 2 pi, and cosine of 2 pi is the same thing as cosine of 0, which is 1. So if I plug in negative 2 pi, so our end behavior is, if we write these as coordinates, negative 2 pi, and then that would give us negative 2 pi plus 1. And then plugging in positive 2 pi, we have positive 2 pi plus 1. Those are those coordinates where our behavior or our graph ends. Now we are getting to the calculus questions, so let's go ahead and switch gears back to the derivatives over here. I've already taken the first derivative, set n equal to 0, solving it, and sine is equal to 1 at pi over 2. And so we can do our sine chart, and we're looking at, we're looking at a couple values, not just one, because we're looking at the interval not just from 0 to 2 pi, but we're looking at negative 2 pi to positive 2 pi. So if I subtract 2 pi, I get negative 3 pi over 2, and then I have positive pi over 2. And if I plug in values in each of these intervals, positive, and it's going to be positive, and it's going to be positive, which means it's increasing everywhere. So we're going to say from negative 2 pi to positive 2 pi, and that means it's not decreasing at all. Okay? No signs alternate, which means there are no max and mins. And so we can move on now to finding the second derivative. Again, just taking the derivative, set it equal to 0, and we found those values plus 2 pi n. So our sign chart here is going to have a few values. It's going to have 3 pi over 2. It's going to have pi over 2. And then if I subtract 2 pi from each of those, I also get negative pi over 2 and negative 3 pi over 2. Kind of running my work together here. And going ahead and plugging in values in each of those intervals, negative, positive, negative, positive, negative. And again, you can go through the work of plugging in values into the derivative there. Remember, we're plugging points in each of these intervals into that derivative. So we can see where it's concave up and concave down, and we can see all of these inflection points. So it's concave up from negative 3 pi over 2 to negative pi over 2, and it's concave up from pi over 2 to 3 pi over 2. So negative 3 pi over 2 to negative pi over 2, and pi over 2 to 3 pi over 2. And then it's concave down everywhere else. And again, we're only looking at from negative 2 pi to positive 2 pi. So I will say from negative 2 pi until negative 3 pi over 2. And then from negative pi over 2 to positive pi over 2. And then from 3 pi over 2 to 2 pi. So that's where it's concave up and concave down. And then those inflection points, we've got quite a few of them to list out now. All of those x values that we see there are inflection points because it's alternating positive and negative at each of them. So I'm going to go ahead and list them out here. Negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. And we want to find those corresponding y values. And again, this is a transcendental function. It behaves a little bit strange. If I wanted to find the exact values, then we would say, okay, negative 3 pi over 2, and then cosine of negative 3 pi over 2 is 0. So that would be negative 3 pi over 2. If I plug in negative pi over 2, negative pi over 2 for cosine, that's going to be 0 as well, and so we've got negative pi over 2. And then plugging in pi over 2, that's also 0 for cosine. The x value is pi over 2, and then 3 pi over 2. And it might be helpful for you to get some decimal approximations for those, just so plotting those points is a little bit easier. But we are ready to go ahead and graph now because we've found all the information that we need. So I'm going to go ahead and plot the points that I know. I know that I have a y-intercept of 0, 1. I know that my graph ends at negative, or the first point would be negative 2 pi, and then negative 2 pi is about negative 6.28, plus 1 would be negative 5.28, so a little bit more than negative 5. And then here would be 6.28 plus 1, so almost 7, or a little bit over 6, 2, 4, 6. And we see those inflection points of where it's changing from being concave up to concave down. So we know it's concave down starting out, and then switching to concave up, and alternating like that. And so if you kind of, again, like we saw the graph already, we can see that it's kind of taking this curved shape as we move from beginning to end of the interval. And that finishes off section 4-5 for us.